Hello student friends, myself R.D. Mahajan, Assistant Professor MIT Aurangabad, presenting my next video on the topic Solution of Ordinary Differential Equation by Laplace Transform, Part 2. Uh, Let us try to solve some examples. First one, solve dy by dt plus 3y is equals to 10 sin t and condition y at 0 is equals to 0 by Laplace transform. Therefore, as per previous two example, we try to solve this one. Given dy by dt plus 3y is equals to 10 sin t. Then taking Laplace on both sides, a Laplace of left hand side is equals to Laplace of right hand side, and while taking Laplace of left hand side we take individual Laplace, and therefore it is Laplace of dy by dt, 3 constant outside, Laplace of y, Laplace of sin t. Applying this standard result for first order derivative, it is s f bar of s function is here y, therefore y bar of s minus y of 0 Laplace of y bar of s and is equals to 10 Laplace of sin t, standard result a is 1 here, 1 upon s square plus 1. Okay, then collecting the terms of y bar of s, we get s plus 3 into y bar of s is equals to 10 1 upon s square plus 1 minus y 0. If you transfer to right hand side, it becomes the value of y of 0 is given as 0, therefore it remains 0, and then dividing by coefficient of y bar of s, we get y bar of s as 10 1 upon s square plus 1 divided by this, it is 1 upon s plus 3. Okay, equation number 1. Here the first half part is completed. Then in second part we take inverse on both sides, therefore taking inverse Laplace transform on both sides, and therefore inverse Laplace of y bar of s, inverse of this 10 is constant term outside, inverse Laplace of 1 upon s square plus 1 into 1 upon s plus 3, and we try to determine inverse by a convolution, as here we have a product of two functions of s. Therefore we know that inverse of 1 upon s square plus 1 is sin t, and the second inverse of 1 upon s plus 3 as here it is standard result as per that it is e raised to minus 80, a is here 3, therefore e raised to minus 3t. One term we call as f of t, second term we call as g of t. Therefore, I will call this as f of t and this as g of t. Or we can interchange, final answer will be the same. Here both the functions having one term of t, therefore we can consider any one of them as g of t. And then finding inverse by convolution theorem. By convolution theorem, inverse Laplace of the product of the two, 1 upon s square plus 1 into 1 upon s plus 3 is equals to integral from 0 to t f of u into g of t minus u du, and therefore it is equals to integral from 0 to t, replacing t by u in this f of t, we get sin u, g of t minus u, replacing t by t minus u here, it is e raised to minus 3 times t minus u du, and therefore it is equals to, splitting this, we get e raised to minus 3t into e raised to 3u. Out of that, e raised to minus 3t is constant. With respect to u, we take it outside. Therefore, it is e raised to minus 3t outside. Integral from 0 to t. Remaining is e raised to 3u. Minus it become plus into sine of u du. Okay. And then using that standard result. Yes, we know that integration of e raised to ax sine of bx dx as e raised to ax a square plus b square divided by a square plus b square multiplied by a sine bx minus b cos of bx. Comparing this result with this standard result, x is here u, e raised to x, coefficient of x is a, therefore here coefficient of u is 3, and sine of bx, b coefficient of u here, it is 1. And then applying this result, it is equals to e raised to minus 3t as it is. Integration of this by this result, the first term is e raised to x, here it is e raised to 3u divided by a square, 3 square, b square, 1 square, in bracket a sine bx, a is here 3, sine of bx, sine u, minus b, 1, into cos of bx, cos of u, bracket close, outer bracket close, and the limits from 0 to t. Okay. And therefore it is equals to e raised to minus 3t uh, 9 plus 1 10 divided by 10 Substitute upper limit for t ust here, therefore it is e raised to 3t multiplied by 3 sin t minus cos t minus lower limit for us 0 e raised to 0 1 into sin 0 0 cos 0 1, and therefore we get it is equals to if you multiply it inside we get 1 by 10 e raised to minus 3t into e raised to 3t e raised to 0, that is 1. Therefore 1 into this 3 sin t minus cos t, and this is minus minus plus 1 into this, therefore plus e raised to minus 3t. Substituting that value in this step, and therefore that L inverse of y bar of s is y of t 10 multiplied by the inverse of this, and inverse of that term is this one, 1 by 10 in bracket 3 sin t minus cos t plus e raised to minus 3t. So that this 10 get cancelled and we get the required solution as 3 sin t minus cos t and plus e raised to minus 3t as the required answer or the required solution of that given differential equation. Therefore, for this example, this result is important to find the value of this integral. Example 2, solve d2x by dt square d2x by dt square plus x is equals to t, and the condition x of 0 is equals to 1 and x dash of 0 is equals to minus 2. X dash of 0 is equals to minus 2. Solve this by Laplace transform technique. Okay. Here given differential equation is of order 2. Therefore given d2x by dt square plus x is equals to t. Taking Laplace on both sides, therefore Laplace of left hand side, Laplace of right hand side, and taking individual Laplace on left hand side, we get Laplace of first term plus Laplace of x, and that is equals to Laplace of t. Applying the standard result for Laplace of second order derivative, it is s square f bar of s, here it is function is x, therefore x bar of s minus s x of 0 minus f dash, here it is x dash of 0, Laplace for the first term, Laplace of x once again, it is x bar of s, and Laplace of t, it is 1 by s square. Standard result. Here n is 1, x raised to n plus 1. 1 plus 1 we get 2 and 1 factorial. Then collecting the terms of x bar of s, we get here s square plus 1 into x bar of s, and all other terms we transfer to right hand side, 1 by s square. The value of x of 0 is 1, therefore minus s, if you transfer it becomes plus s. X dash of 0 minus 2 minus it becomes plus 2, if you transfer to right hand side it becomes minus 2. Okay, and then dividing by the coefficient of x bar of s, we get x bar of s as 1 by s square plus s minus 2 whole divided by s square plus 1, and that is equals to, taking separate division, it is s square into s square plus 1 s upon s square plus 1 and minus 2 upon s square plus 1, and then taking inverse on both sides, and therefore inverse Laplace of x bar of s, inverse of right hand side, and taking individual inverse of the first, inverse of the second, and minus 2 constant outside, inverse of third term. And we call this as equation number 1. Okay, and then this is standard result. Inverse of this is cos t, inverse of this is sin t, and here it is a product of two terms, therefore finding this by convolution theorem. By convolution theorem. What we know? We know that inverse of first term 1 by s square is t raised to n minus 1, 2 minus 1, that is 1 by 1 factorial, means it is t, and the second inverse of 1 upon s square plus 1 as sin of t. One term of t, one term of t. Therefore, any one we can consider. Therefore, I will consider this as g of t and this as f of t. Okay, and then finding by convolution we get. Therefore, we have inverse Laplace of 1 by square into 1 upon s square plus 1 by convolution theorem. It is integral from 0 to t f of u into g of t minus u du, and therefore it is equals to integral from 0 to t f of u. Replacing t by u here, it becomes sin u, and in g of t replacing t by t minus u, we get t minus u du. Therefore, here it is a product of two terms of u integrating by generalized part. Integrating by this one is algebraic and this is trigonometric. Therefore, we consider the first term as t minus u. Okay, therefore, first term t minus u. Integration of sine is minus cos u minus derivative of this with respect to u. It is constant term, its derivative 0. Its derivative is minus 1. And its next integration of cos is sine with this minus sign. Therefore, it is minus sine u. And next derivative 0. We stop here and limits from 0 to t. Substitute the upper limit for u as t here. T minus t we get 0, therefore this term becomes 0. Minus minus minus, 3 times minus sine of t minus u has 0 here, therefore it is minus t cos of t, and this minus 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 3 times minus cos 0 and sine 0. And therefore, if you simplify it, this one is, I will write down the first term as positive, minus minus it becomes plus t cos 0 1, sin 0 0, and this one is minus sin t. Substituting that value in equation 1. Therefore, inverse of x bar of s is x of t. Inverse of this term is t minus sin t, obtained by convolution theorem. Inverse of this one is cos t, and minus 2 times inverse of 1 upon s square plus 1 is sin t. Okay, and therefore we get t plus cos t and minus sin t minus 2 sin t, we get minus 3 times sin t as x of t as the required answer. Therefore, in second part, I explain two more examples how we can find the solution of ordinary differential equation by using Laplace transform. Two more I will explain in third part. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates of the new videos. Thank you very much.